Hey guys, today we're talking about 2.5, which is all about compound inequalities. Now, compound inequalities is basically just taking two inequalities that we've been used to working with and combining them together into a single thing. And we've got two different ways that those inequalities can interact with each other. We've got two different ways that we'll classify compound inequalities. We have something called an AND inequality and an OR inequality. And how they interact with each other is based on how their solutions interact. So if we take a look and see first, the graph of a compound inequality with AND intersects the graph of the two individual inequalities. So if we look at this one here, x is greater than x is greater than or equal to 2 is that top inequality. We can see my boundary at -2 or at +2 and shaded to the right. My bottom one here at +5, x is less than 5, and shades to the left. If I were to take both of those two inequalities and combine them into a single number line, we can see that my graphs intersect between +2 and +5. So on my number line for the compound inequality, since my solutions overlap, right? They point towards each other, they overlap on the number line. We have the possibility of solutions, of x values in this case, that are true for both of my original two inequalities. I could be both bigger than or equal to 2 and less than 5, which is why we're shaded in between these two. When that's the case, when you could be true for both of them, you could say it's an AND problem, because again, my numbers, my solutions here that are all in this little section here between +2 and +5, they're true for both of my inequalities. It's true that x is bigger than or equal to 2 and less than 5. So that's what an AND problem looks like. I've got a different way of formatting this. This right here that I'm highlighting in red. This is how we write up my inequality for an AND problem that combine them together and down into a single inequality. I'm just emphasizing here that my x value, my solutions, are between +2 and +5. So the way that I would read this, -2 is less than or equal to x is less than 5. So it's between +2 and +5. So again here, ooh, that's still a highlighter. So again here, AND means in. So here, that means that AND tells us in between. Or vice versa, if you're starting with a problem and you know that that thing has to be true in between those two values, you know you're dealing with an AND problem. Now, OR problems are a little bit different. In OR problem, the solutions don't interact with each other at all. They're two totally different inequalities. They point opposite directions, so that's why in this case, I can't be true for both of them, and that's why I call it an OR problem. I can be either this or that. I can either be, in this case, less than or equal to -2, or I can be greater than 1. I can't be both, so that's why it's an OR problem. If you combine those two things together in a number line, they're going in opposite directions. They don't overlap at all, so it's an OR problem. So in this case, again, OR means opposite directions, or in the case of, if we're looking at in between was our phrase for AND, outside of my two boundaries is how we would classify an OR problem. If you know it's bigger than this or smaller than that, it's an OR problem. Okay. Now, most of what we have to deal with is just going to be solving them. So they're already going to be formatted for you, and they're going to tell you already if it's an AND problem or an OR problem. So you just need to be able to handle when we have those as the options. So if we take a look at box 2 is just working on solving an AND problem. So looking at number 1 here, we're trying to solve -4 is less than x minus 2 is less than 3. Now this is the part that gets to be a little bit funky, because if you look at our inequality, and a normal one that we deal with, if we're going through and solving for our variable, what you add on the left side, you also have to add on the right side, or vice versa. But in this case, because we have two different inequalities, we kind of have three different sides or three different sections of my inequality. I have my left and I have my right, but I also have this middle section now. So what happens here is when I'm going through and trying to solve for my variable, I'm going to get x by itself in the case of number 1, I'm going to have to add 2 in order to get rid of negative 2 to get to just x. But when I do that, I have to also make sure I add it on the left and the right side. All 3 parts of my inequality here have to have the same thing happen to them in order for me to maintain a true inequality. So here, if I add 2 in the middle to get it just to be x, I have to add 2 on the left and get negative 2 is less than x is less than 5 on the right side. 3 plus 2 is 5. And that's my answer. Negative 2 is less than 5 is less than x. So my x value is negative 2 is less than x is less than 5. So my values are all between negative 2 and positive 5. So now when I go to graph these, negative 2 and positive 5 are my boundaries. For my number line, I don't have the same requirements as we did in the previous sections where you have to have at least 5 values on your number line. For this, my requirements are that just your boundaries are there, both of them are there on the number line, and that you have a consistent scale to your graph. So in this case, I just have it labeled from negative 5 to positive 5, just because that's what fits on my number line here. So when I go to graph this, I have a boundary at negative 2, I have a boundary at positive 5, and I'm going to be shaded in between those two. So you've got your options again on how you want to shade. I'm usually an up and over arrow person. So in this case, if I go up and over, I just have to make sure I stop again at positive 5. Now notice here I used open circles for both of these, and that's because on your number line, or on your inequality, when you're dealing with a compound one like this, the symbol next to your number determines what circle you use. Just remember again from earlier this chapter, less than and greater than means an open circle, less than or equal to, greater than or equal to means a closed circle, so a shaded in circle. In this case, both of my inequalities were just less than symbols, so that's why they're both open circles. You might have some eventually, like with number 2 that we're about to look at, where it is both. It's one of each. So let's actually go ahead and take a look at that one. For number 2, a little more complicated, but I'm still doing the same process. I'm still solving for x. So I'm going to add 1 in the middle, which means I have to also add 1 in the left and the right. That gives me negative 2 is less than negative 2x is less than, oh, sorry. I don't know why I didn't subtract. I should be subtracting. For number 2, we're going to start by trying to solve for x. So first step here should be subtracting 1 from the middle term, which means I have to also do that to the left and the right. So that gives me negative 4 is less than negative 2x, less than or equal to 8. And now I have to get rid of that negative 2 attached to my x in the middle. So I'm going to divide by negative 2. And again, what I do in the middle, I also have to do on the left and the right. Now here you have to be careful because I am dividing by a negative number. And just like I did in 2.3, if I multiply or divide by a negative, I have to make sure I flip the direction of my inequality. So here I'm going to both divide my numbers, which in the middle cancels out. Negative 4 divided by negative 2 is a positive 2. And now I'm going to have to flip that inequality. So now it's going to go the other direction. In the middle now I just have x. Flip my inequality on the other side there. 8 divided by negative 2 is a negative 4. And that is my answer there. Positive 2 is greater than x is greater than or equal to negative 4. Which makes sense because if you look at it in terms of the number line, I have my x values are between negative 4 and positive 2. If I forgot to do that, I'm going to just pretend over here in the yellow that we forgot to flip 2x negative 4. So if you had it written up this way, my x is supposed to be between 2 and negative 4, which is fine. But if you look at my inequality symbols, these two things are telling me that my x value is supposed to be bigger than 2 and smaller than negative 4 at the same time. And that does not work. We know that that's not possible. I can't be between negative 2 or negative 4 and positive 2 while being bigger than 4 and bigger than 2 but smaller than negative 4. So that should tell you if you did that and you forgot to do that inequality flip, that should remind you that this is not possible because it can't be bigger than 2 but smaller than negative 4. So you have to flip the inequality. Since we remembered that the first time around, let's go ahead and just graph this guy. 2 less than or greater than x greater than or equal to -4. Again, here I'm looking at what my inequality symbol is right next to the number, so I know what kind of boundary I'm going to be drawing. In this case, at -4, I've got a solid circle because it's or equal to right there. And at +2, I've got an open circle because it was just greater than. My x's are shaded between those two, so let's just shade in a different way to get some different people. Let's say you're a highlight person, so you're going to highlight there. And that's what you want to do. Good for you. You do you, boo-boo. That's it. -2 or -4 up to 2, solid circle at -4, open circle at +2. For box 3, we're working on solving OR problems. Now these ones can be a little more tedious, meaning they're going to be more time consuming, but they really should be easier for us because for an OR problem, right, we know they go in opposite directions. They're totally separate from each other. And that's how we're going to go through and solve these. They're totally independent problems from each other that you're just going to be solving at the same time for each problem. So if I'm looking at number 1 here in box 3, if I'm solving this OR inequality, I've got 3y minus 5 is less than -8, or 2y minus 1 is greater than 5. Each of those two problems are separate from each other, so I'm just going to go through and solve each of those independently. So I'm going to do the left one here in blue. 3y minus 5 is less than -8. I'm going to add 5 on both sides to get my y term by itself. That gives me 3y is less than -3. And then I divide by 3 on both sides to get y is less than -1. Didn't have to flip my inequality because I divided by a positive number. Sorry if I went through that kind of quick, but you should know what you're doing on those kind of problems. So I've got my first part done. -1 is my boundary. For the right part, I'm going to do in red. I'm going to start by adding 1 on both sides. That gives me 2y is greater than 6. So when I divide by 2 on both sides, I get y is greater than 3. And that is my answer. I've got those two pieces. Either y is less than -1 or y is greater than 3. Which again, makes sense looking at my number line. They're going to be going in opposite directions. Bigger than 3, smaller than -1. Makes sense in terms of the actual physical layout of stuff. I'm just going to keep it in 2 different colors so it's easier and you see which one goes with which. For my blue one on the left side there, y is less than -1. That tells me I've got an open circle at -1 because it's just less than. And since I'm less than, that goes to the left. Or you can look at the direction of my inequality symbol is to the left. The right one in red, y is greater than 3. Again, open circle since it was just greater than. And I am going to the right for my shading. So I did good. They're going away from each other. That's what I want. I get for those two boundaries. If you, again, go through and solve these and you have them pointing the same direction, they're both pointing to the left, they're both pointing to the right, or they're pointing towards each other for an OR problem, that means you probably did something wrong, and most likely you forgot to flip your inequality somewhere along the way. So take a look and see all through your problem to see if there's a spot where that happened, or it could just be that you shaded the wrong direction. Okay. For number 2, again, another just example. I'm going to do the left in blue, the right in red. So 2x plus 6 is less than or equal to -2. I'm going to start by subtracting 6 from both sides. 2x, not y. 2x is less than or equal to -8. So then I divide by 2 on both sides, and I get x is less than or equal to 4. -4. Over here, I'm going to add, I forgot to switch to red. Over on the right side, 4x minus 5 is greater than 3. I'm going to add 5 on both sides. 4x is greater than 8. So I divide by 4 on both sides, and I get x is greater than 2. So again, my answer, combining those together, my x could either be less than or equal to -4, or my x could be greater than 2. So when I go to graph that bad boy there, in blue, I've got a closed circle at -4 since it was or equal to, and I am less than, so I'm going that way. In red, open circle at +2 because it was just greater than, and shaded to the right because it was pointing to the right. Greater than is right. So that's OR problems, and that's really most of what you'll have to do. The box 4 that we're going to do together for the last one here is going to be a word problem, so we'll go through and just kind of talk through how to handle those. But really, again, most of what you're going to have to do when it comes to the test next Friday will be just solving these compound inequalities after they're already set up and graphing them as well. So taking a look at box number 4, the problem we're given here is that our cell phone has an operating temperature of 0 degrees Celsius to 35 degrees Celsius, which all electronics have that. The manufacturer has to say, hey, these are the safe temperatures for which your electronic or your device, your thing, will work properly in. So what we're asked to do is write an inequality that represents the situation, and we're asked to identify a positive and a negative non-solution. So in this case, what we have to ask ourselves, again, we go back to those two questions. Is it an in-between, or are they going away from each other? Are they outside? So here, the numbers that would work in my inequality, the numbers that are going to work in this situation, my temperatures that are safe for my phone are going to be between 0 and 35, right? So since it is between, we are dealing with an and compound inequality. So when I write this up, my variable is going to be between 0 and 35 on the inequality. So the only other thing I have to define is my variable. Since I'm dealing with temperature, I'm going to use T for my units, or for my variable. My units here are in degrees Celsius. So when I write my inequality, if my temperature has to be between 0 and 35, 0 less than or equal to T, less than or equal to 35, would be that inequality. That's the inequality that represents my situation, because those are the safe temperatures. I can be 0 degrees, I can be 35 degrees, I can be any number in between those two, but as soon as we get outside of that range of temperatures, my phone starts acting funky or not work properly. So for the last part there, I need one temperature that is a positive non-solution, meaning a temperature that's too hot for my phone to handle, which really just means any number bigger than 35 is going to be a positive non-solution. So the smallest one you could say is 36 degrees Celsius. You could say 100 degrees Celsius. You could say 2,437,183 degrees Celsius. Any of those work as long as it's a positive number bigger than 35. For my negative non-solution, these are temperatures are going to be too cold for my phone. Negative non-solutions would literally be any negative number. Negative 1 degrees Celsius would work. Negative, 37 degrees Celsius. Negative 1,429 degrees Celsius also works. Any of those things work to be non-solutions. That's all I got for you guys. Your homework that you guys will have time to work on tomorrow, Thursday in class, is going to be pages 85 and 86, 4 through 30, just the evens. As always, if you have questions, concerns, thoughts, or ideas, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day, and I'll see you guys tomorrow.